It is also a 1 mark question. It says the yarn manufacturing technology that uses perforated drums for twisting. Option A is ring spinning, second one is rotor spinning, third one is friction spinning, fourth one is air jet spinning. So if we talk about which type of technology uses perforated drums, so if you have read these spinning processes, then you must answer. It is a very simple question. If you know about friction spinning, so option C is the right answer. And talking about the explanation part, then friction spinning you on the drift or the drift spinning, matlab, it is said as drift 1, drift 2, drift 3. These are different parts of the friction spinning machine. So it is suitable for spinning coarse count of yarns. So generally heavy count of yarns are used in this, and it consists of three distinct operations that includes feeding of fibers, thereafter fiber integration, and thereafter twist insertion. So these three processes are included in this friction spinning process, and this technology uses perforated drums for the twisting process. So option C is the right answer. So now coming to the next question. This question says in roving frame the distance between top and bottom aprons at the exit point is maintained by. So if you have read about the roving frame, thereafter ring frame, these are all yarn manufacturing processes, and these manufacturing process, the machines, the equipments, the proper functions of these individual parts are very important. So if you have read about the roving frame, the distance between the top and the bottom aprons, the distance, this distance is maintained by a spacer. So it is a very straightforward question. So in this question the right answer is option number A, spacer. So the distance between the top and the bottom is maintained by a spacer. So just read these things carefully. These are to the point questions. If you know, you can answer it directly. Otherwise you cannot answer these questions, since these are straightforward theoretical questions. It is a 1 mark question. Now looking forward to the next question. The number of fibers, each of 40 mm length and 0.16 text fineness, in a tuft of 24 milligram mass is. So you have to find the number of fibers. It is also a 1 mark question. So it is a direct simple textile calculation. So what is the length of single fiber? So it is 40 mm. It is written. And what is the mass? It is 24 mg. So if we write mass of tuft, is given as 24 milligram. If we write it in grams, so it becomes 24 into 10 ki power minus 3 gram. And fiber fineness is given as 0.16 tex, means fineness is given as 0.16 tex. We can write tex as gram per 1000 meter. This is the unit for tex. It is gram per 1000 meter. And what is the unit for denier? It is gram per 9000 meters. So if it is the length for 1000 meters, so if we have to calculate for weight of 40 mm length fiber, then it comes out to be 40 mm means 40 into 10 ki power minus 3 meter into, what is the fineness for this? 0.16 gram upon 1000 meter. So meter to meter got cancelled, and you can solve this in grams. So if you will solve this 0.16 into 40 into 10 ki power minus 3 gram. So how you will calculate the number of fibers? Number of fibers means Mass of tuft upon weight of 40 length fiber. So mass of tuft is given as to be 24 into 10 ki power minus 3 grams. Since number of fibers is asked, then there will be no units because it is a number, and divided by 0.16 into 40 into 10 ki power minus 3 grams. So gram to gram got cancelled, and what we are left with is, if you will solve, it will also get cancelled, and if you will solve 5 6 10, and when you will solve, then it comes out to be 3750. These are the number of fibers present in this mass and particular fineness. I think it must be clear to you. Now coming to the next question. This is also a 1 mark NET type of question. It is said that twist per inch of a cotton yarn of 36 NE count produced with a twist multiplier of 3.5 per inch into under root of NE is. So you have to find twist per inch, means TPI. If you know the formula for twist per inch is equal to twist multiplier into under root of count in indirect count, means under root of NE. So you have to find twist multiplier is given as 3.5 into under root of NE is under root of 36. It is yarn count in indirect form. So if you will solve that, 3.5 root 36 is 6. So it will come out to be 773 is 21. So TPI is 21 and it is the answer. You have to answer in integer or any form. So 21 is the right answer. I think it is clear to you. Now coming to the next numerical type question. So if you notice the pattern of GATE examination, then you can easily find that they ask in a similar pattern every year, or then the patterns are repeated and the questions are modified in one or the other form. So if you focus on basics and if you focus on your fundamentals, then you can easily answer these questions very clearly. Now coming to the next question. In winding, if the traverse speed and the package surface speed are same, then the angle of wind in degree is. So this is a fabric manufacturing type numerical NAT question. So it is also a 1 mark question. So if you know, in winding process, the angle of wind that is represented by theta, so tan theta is equal to Vd upon Vs. So if Vd and Vs is package surface speed and traverse speed, so if this traverse speed and the package surface speed are same, so both are same, since both are same, then the value comes out to be 1. So you have to find the angle of wind angle. So in this case, tan theta is equal to 1, theta is equal to tan 45 degree, so theta becomes 45 degree, and this is your answer. You have to write in degrees. If it is asked in radians, then you have to divide by 180, then you can find the radian. So it is asked in degree, so the answer will be 45. I think it is clear to you. Now coming to the next question. So it is also a 1 mark YM question, yarn manufacturing question. It says that if the ratio of the linear densities in denier of two circular fibers is 3, then the corresponding ratio of their diameters rounded off to 2 decimal places is. So you must remember what is the relation between the denier and the diameter. So basically denier is a direct form of count, denier and tex. Denier is gram per 9000 meter, whereas tex is gram per 1000 meters. So if we talk about denier is pi d square by 4 into L into rho. So if you know the relation between the denier is directly proportional to diameter ka square. So So two deniers are given. Linear density in deniers is given as 3. So denier 1 upon denier 2 is equal to d1 upon d2 square. So denier 1 upon denier 2 and diameter of the corresponding diameters you have to find, and the ratio of denier 1 upon denier 2 is given as 3. So d1 diameter of 1 upon diameter of 2 square is 3. So you have to find the ratio of the corresponding diameters, means ratio of d1 is to do d2 you have to find. So d1 upon d2 will come out to be under root of 3. Under root of 3 is 1.732. So would it be the right answer? It is the right answer, but make sure you have to answer this in two decimal places. So in two decimal places, the answer will come out to be 1.73. It is the right answer. So 1.73 is the correct answer. I think it is very much clear to you. This is the basic correlation between the denier and the diameter of the fiber. So now coming to the next question. In a modern high-performance blowroom line, the correct sequence of the machines is option A, automatic bale opener, then blender, then coarse cleaner, then fine cleaner. Option B, automatic bale opener, then blender, then fine cleaner, then coarse cleaner. Option C, automatic bale opener, then coarse cleaner, then fine cleaner, then last one is blender. And option D says that automatic bale opener comes first, then coarse cleaner, then blender, then fine cleaner. So if you read about high performance modern blue room line, the process efficiency and the flexibility is very high in these high performance blue room line as compared to a conventional blue room line. It consists of coarse cleaner followed by blending, and then fine cleaning is done. So first one, what is the function of blue room? It opens all these seed coat particles, that is the cotton. When it comes, it contains many types of impurities, that is seed coat particles, because it is extracted directly. So these fiber individualization as well as the removal is done. Individualization is done in after blue room. Then it is then the fiber goes into carding, where individualization of fibers is done. But in glue room, all these cleaning kind of things are done. So first one is the bale is opened. So this is common for all. But if you look at when the bale is opened, then there are particles. First one, coarse particles, that is high in size. These are first clean, then they are blended. In during the blending process, these coarse particles are cleaned and then blended, so that the when the blending occurs, then fine cleaning can be done easily. So option D is the correct option in this case. Automatic bale opener, then coarse cleaner, then blender, then fine cleaner. So option D is the correct option. Now coming to the next question. This is also a 2-mark question which says that as compared to the cylinder, Doffer has low rotational speed and lower wire point density. Second one is lower rotational speed and higher wire point density, higher rotational speed and lower wire point density. Option D is higher rotational speed and higher wire point density. So a cylinder and Doffer, this is both is used in the case of carding. So carding machine is we are talking about carding machine. So if you know about the rotational speed sequence in carding machine, then the cylinder speed is highest, followed by liquor in, then comes the doffer, then comes the doffer. So if the cylinder surface speed is higher than the corresponding speed of the doffer. This speed difference means that the web is condensed uh, on the surface of the carding machine. So what is doffer? Basically, doffer is a revolving cylinder or a vibrating bar with teeth in a carding machine which doffs or strips off the fiber from the cards. And if we talk about the setting between the cylinder and the doffer, is closest setting in the card. The setting mainly depends upon the cylinder speed, the hank of the delivered sliver. so on and so forth. So uh, as you can see that the cylinder has highest speeds, so the doffer has lower rotational speed and also the lower wire point density, because since cylinder is highest, we are in this question it is talking about the doffer. Doffer has both lower speed and lower wire point density compared to the cylinder. The cylinder has the highest speed come in the entire carding machine, so option A is the correct option in this case. Now coming to the next question. Assuming no fiber loss in draw frame, if draft is equal to doubling, then the delivered sliver as compared to the fed sliver will exhibit option A decreased mass variation and higher linear density, option B increased mass variation and lower linear density, option C improved fiber orientation without change in linear density, option D poor fiber orientation without change in linear density. So in this case what it is said that draft is equal to doubling. Draft in this case it is said draft is equal to doubling. So what it means basically, how if the drafting the number of drafts given in this case is equal to the number of the doubled slivers that is used. So why this is done, if similar drafting means stretching, the fiber stretches in case of drafting, but in case of doubling the sliver quality improves by doubling the fibers. So what actually happens, if the drafting is equal to doubling, then there will be no change in linear density, since how much the we did the drafting, the exactly on the same number we did the doubling, so no change in the linear density will take place. But what would be the use of drafting then? So drafting improves the orientation of the fiber, so no change in linear density, but the improved fiber orientation will be improved due to the drafting and the doubling that is done on the fiber surface. So option C would be the correct option, improved fiber orientation without change in linear density. So this was also the theoretical question, but you need to know the basics of draw frame and combing process. What is the role of drawing and doubling process? So the drafting is multiplied, whereas the doubling is divided. If you have solved the numerical type of questions of drafting and doubling, so I think it is very much clear to you. Now coming to the next question that says that. So coming to this question, it says that in melt spinning, the mass throughput rate of polymer is 210 gram per minute, the winding speed is 3000 meter per minute, and the linear density of the yarn produced is 200 denier. The effective draw ratio rounded off to 2 decimal places is, you have to find the draw ratio in this case. It is a 2 mark question, NET type of question, and there is no negative marking in these types of questions, so you can answer this question. So just looking at the linear density, just starting this question, linear density of the polymer is if you will write, then the mass throughput rate upon the winding speed, it is the linear density. So just write 210 gram per minute upon 3000 meter per minute. So dot minute to minute got cancelled, and we get 210 upon this. So if you solve 21 upon 300 means 7 upon 100, 7 gram per 100 meter. And if you know, if we multiply this by 10 and also denominator by 10, so gram per 1000 meter becomes tex. The unit of tex is gram per 1000 meter. We have multiplied and divided by 10 10 respectively, so that the unit, so that the entire nothing changes and it remains the same, and we can replace gram per 1000 meter by tex. So it will, the linear density of the polymer will become 70 tex. and if you know about what is denier, gram per 9000 meter, so it comes out to be 70 ticks. And what is given, and also it is said that linear density of the yarn is linear density of yarn is given as 200 denier. 200 denier means 200 gram upon 9000 meter. So if you will write this 1000 divided by 1000, so it will come out to be 200 upon 9 into 1000 meter means 200 by 9 ticks. So this, the linear density of the polymer is 70 ticks and linear density of the yarn is 200 by 9 ticks, and you have to write the effective draw ratio. So therefore the effective draw ratio is the linear density of the polymer divided by linear density of the yarn. So draw ratio will become 70 ticks upon 200 by 9 ticks. Ticks to ticks got cancelled, and what we are left with 70 into 9 upon 200, that means 3.15. So 3.15 is the correct option answer, and you have to write in 2 decimal places, so 3.15 is the correct answer. I think it is clear to you. What we have done in this question is we have found that the linear density of the polymer and the linear density of the yarn was already given. Just we need to convert these in the similar units and then divide by the draw ratio. Draw ratio has no unit, and so the answer is linear density of the polymer upon linear density of the yarn. This is the draw ratio of the effective draw ratio of the system. So we have found this answer. Now coming to the next question. Moving off to any count is fed to a ring frame set with a mechanical draft of 30 if the length of the drafted strand delivered from the nip of the front rollers is reduced by 3% due to twist. The count in any of the yarn rounded off to 1 decimal place is. So the yarn count is given in any is an indirect count. So the draft is delivered count upon feed count. So the delivery count, feed count is said to be 2 NE and the draft is 30 mechanical draft. So 30 into 2 will become your delivery count, delivered count, and it is 60 NE. And when you will, this will to be 60s NE. It is delivered count. But due to reduction in length due to twist is 3%. So if how much the length will be reduced due to twist, reduction in length due to twist is 3%. 3% of what? 3% of 60. It will come out to be 1.8. And if you know that if the length is reduced, then the yarn becomes finer or coarser. If the length is reduced, then the yarn will become coarser. That is, if the value of any is less, then the yarn is coarser, and if the value of any is high, then the yarn is finer. If for example 20 is any and 40 is any, which yarn is finer and which yarn is coarser? So 40 is any yarn is finer, whereas 20 is any yarn is coarser. And if we talk about the text system, it is a direct system, and here 40 text value is coarser and 20 text value is finer. So this is a simple framework that you need to be clear with. So the if the yarn is so the count of the yarn due to after the reduction in length would be so count in any of the yarn would be 60 is any minus 1.8. 60 minus 1.8, it would come out to be 58.2. 58.2 any would be the right answer, and you have to write in one decimal place. So the correct answer is 58.2. It was a 2-mark question of GATE TF 2021. I think it is very much clear to you. Now coming on to the next question. Meant the diameter of all bottom rollers is 28 mm, the back zone draft is 1.3 and the front zone draft is 6. If the back bottom roller is eccentric, then the wavelength in mm of the front zone draft is 6. If the back bottom roller is eccentric, then the wavelength in mm of the resulting fault in the drawn sliver rounded off to 2 decimal places is. In this question, you have to find the wavelength of the resulting fault of the drawn sliver. In this case, how it is arranged? It is arranged in this pattern. These are the rollers that are arranged in this fashion. 3 cross 3 drafting rollers means 3 rollers above and 3 rollers in bottom, and these are arranged in a similar pattern. So, and the diameter is said to be 28 mm. 28 mm. 28 mm is diameter. 28 mm is diameter. So if we calculate the front zone draft as 6 and the back zone draft is 1.3, so the total draft is back zone draft into front zone draft means 1.3 into 6, that will come out to be 7.8. It is the total draft. And if we have to calculate the wavelength of the resulting fault in the drawn sliver, then the wavelength of resulting fault is pi d into total draft. It is a formula, so pi is 3.14, diameter is given it out to be 28, and the total draft is said to be, we have calculated is 7.8. When you will solve this, then it will come out to be around 686.1 mm. And so you have to write in 2 decimal places, and the correct answer is 686.10. It is the wavelength of the resulting fault in the drawn sliver is 686.10. It is the correct answer. I think you have understood. This was also a 2-mark question of NAT type from the drafting arrangements. So you need to be clear what is the formula for total draft and what is the formula for wavelength of the resulting fault pi d into total draft, because total drafting helps in the improving the orientation of the fiber, resultant fiber. So the total draft is calculated using the back draft multiplied by the front zone draft. So in this case it was eccentric. Now coming on to the next question. Now coming to the next question, that is the mass of 120 yards of cotton is 3 gram. The count in any of the yarn is rounded off to 1 decimal places. So this is a basic textile calculation question. So just solving, 1 yard is equal to, I think you must be knowing that 1 yard is equal to 0.9144 meters. So 120 yard length would be 120 yards would be 120 into 0.9144 meters. So it will come out to be 109.72 meter. So gram per meter of cotton fabric would be gram is given as 3 gram per 109.72 meter. So when you solve this, it will come out to be 0. When you solve this, it will come out to be 0.0273. 0.0273. So you have calculated gram per meter of cotton. So thus, therefore, the count in any of yarn will be, the formula is 0.5905 upon gram per meter. So we can easily calculate this part. 0.5905 upon gram per meter is 0.0273. If you calculate this, it will come out to be 21.6. So the NE is 21.6. The count of the yarn is 21.6 NE. I think it is clear to you. So this was the simple calculation part. NE is the indirect count, and indirect count is calculated as 0.5905 upon gram per meter. And just you have to remember this, the relation between yard and meters. It is very important because the question was given in yards and you have to convert it into meter. If you do not know this relation, then you cannot solve this question, because the question and the count calculation is also you have to find the gram per meter only. So just remember what is yard, what is pound, and what is the value of pound. 1 pound is equal to 453.5 lb grams. 1 lb is equal to 453.5 grams. So so on. You can calculate these types, and you must learn these basic calculations and basic formula for textile calculation. Now coming on to the next question.